Hi, my name is Alyssa Brown, and this is my final project on modeling Greek mythology with differential equations. In Greek mythology, Hercules was tasked with 12 labors by Eurystheus. In the fifth labor, Hercules was asked to clean Augeas' cattle yard in 1 day. To complete this, Hercules placed a bet with Augeas that he could clean the yard in a day, where he would be rewarded with a tithe of the cattle if successful. Hercules cleaned the cattle yard by filling the stables with water from 2 nearby rivers, Alpheus and Peneus. Then he made a hole in the foundation of the stables to drain the dirty water and finish the fifth labor. Here is a diagram of Hercules' method for cleaning the stables. We can create a differential equation to show the water draining from the hole in the stable floor, shown here. The variables in this equation are little a is the cross-sectional area of the drainage hole in meters squared, big A is the area of the stables in meters squared, G is the acceleration due to gravity in meters per second squared, H is the height of the water in the stables in meters, and T is time in seconds. The stable is assumed to be 740 meters long, 400 meters wide, and 2 meters high. So the area of the stables big A is 296,000 meters squared. The volume of the stables is 592,000 meters cubed, and with the stables filled with the river water, the initial height of the water is 2 meters. The rivers filled the stables before the hole was formed at a rate of 55 meters cubed per second. Dividing the volume by this rate, Hercules filled the stables in 3 hours. The hole at the bottom of the stables has a radius of 1 meter and a cross-sectional area little a of 3.14 meters squared. The acceleration due to gravity, g, is 9.81 meters per second squared. On the right, you can see the differential equation with these parameter values filled in. To see if Hercules did in fact complete the clearing of the stables in less than 24 hours, we can solve the differential equation to find the time it takes him to drain the stables. This is a separable differential equation, so we can separate the equation to integrate it. Then after integrating it, we can solve for c using the initial condition of the initial height of the water being 2 meters. We find that c is around 2.83. We can plug that into the equation to find the analytical solution for the height of the water with time. From this analytical solution, we can find that it took Hercules about 17 hours to drain the stables. Adding on the 3 hours it took him to fill the stables with water, we find that it takes him about 20 hours in total to clean Augeas' stables, meaning he did complete the fifth labor in time. We can also model the differential equation showing how the water drained from the stables using Simulink, and here is a block diagram showing the differential equation model with the parameter values filled in. On the Simulink scope graph, we can see that the height of the water reaches 0 around 6 times 10 to the 4th seconds, or around 17 hours, which does match our analytical solution. From both the Simulink model solution and the analytical solution, Hercules drained the stables in about 17 hours. Hercules also took about 3 hours to fill the stables with the river water before creating the hole in the foundation. So Hercules took about 20 hours in total to clean the stables with the water from the nearby rivers, meaning he did finish the fifth labor in less than 24 hours. We can also change some of the parameters and see how it affects the storyline of Hercules' fifth labors. Here, we change the height of the stables to 5 meters, so the initial condition of the water would be 5. Also, since we're changing the height, the volume of the stables would change, meaning it would take 7.5 hours to fill the stables with this new volume. In the zoomed-in scope graph, we can see that the height of the water reaches 0 in around 9.4 times 10 to the 4th seconds, or about 26 hours. We can also change the stable height to 3 meters, which is only a meter more than the actual height in the story, making the initial condition for the height of the water being 3. With this height of the stables, it would take 4.5 hours to fill the stables with water. In the zoomed-in scope graph, with this initial condition, we can see that the height of the water reaches 0 at around 7.5 times 10 to the 4th seconds, or in about 21 hours. So, from the height parameter, we can see that if the stable height was 5 meters, Hercules would take 33.5 hours in total to complete the cleaning of Augeas' stables, and would not finish the labor in time. If the height was even only 3 meters, he would still take 25.5 hours to complete the task and would not finish in time. So we can conclude that Hercules was lucky that the stable height was 2 meters, as if it was much higher, he would not have finished the fifth labor in time using this method. We can also see how changing the drainage hole area would affect the storyline. So if the drainage hole radius was 2 meters, little a would be 12.566 meters squared, and you can see that in the block diagram I changed the little a value. In the zoomed in scope graph, you can see that with this new drainage hole area, the height of the water reaches 0 in around 1.5 times 10 to the 4th seconds, or only about 4 hours. So with this larger size drainage hole area, Hercules would drain the stables in only 4 hours, allowing him to completely clean the stables in about 7 hours. So we can conclude that increasing the size of the drainage hole would make Hercules' time to finish the 5th labor significantly shorter. So overall, from our differential equation model of Hercules' method for cleaning the stables, we found that Hercules finished the 5th labor in about 20 hours, which helps to prove that he did in fact complete the 5th labor in time. Also, we found that if the stables were much taller, he would not have completed the labor in time using this method. We also found that if Hercules made a larger drainage hole, he could have completed the 5th labor in significantly less time. Overall, with this differential equation model, we can check the validity of Hercules' story, and we can see how changing the situation slightly can drastically impact the storyline of the 5th labor. And here are the sources that I used for this project. Thank you!